This presentation is about theorems on limits of a function. There are many limits to a function, but for the purpose of this presentation, we will focus on the first 5 theorems. Let us look at the theorem one step at a time. The first of this is the limit of a constant is that constant. In symbol, we have this. This means that the constant value is also the limit. The constant value is represented by C, and what's the constant value is the answer to this limit. I wanted to emphasize that this symbol means x approaches A. Hence, this symbol is read as the limit of C as x approaches A is equal to C. As an example, let us have this. Limit of 5 as x approaches 4. To determine our answer, what we need to look is the constant. As we look at the symbol, the constant is C. With this example, our constant is 5. Hence, that will be our answer. Therefore, we have limit of 5 as x approaches 4 is equal to 5. Let us have another example. If I have limit of 10 as x approaches 5, again, the constant value here is 10. Since 10 is the constant value, the answer will be 10. Hence, we have limit of 10 as x approaches 5 is equal to 10. That's all about the first theorem. Let's have the second one. Limit of identity function. In symbol, we have this. This means that the identity function limit is equal to the approaching value of x. Again, this is read as limit of x as x approaches A is equal to A. The approaching value is A, hence that will be the answer in this theorem on limits. Let us have an illustration. Let us consider that we have limit of x as x approaches 7. As I have mentioned, the approaching value is our answer. Our approaching value is 7. Hence, the answer with this is 7. And we have limit of x as x approaches 7 is equal to 7. Let's have another example. Limit of x as x approaches 8. The approaching value of x is 8. Hence, our answer is 8. So we have limit of x as x approaches 8 is equal to 8. That's the second theorem. Let us have the third one. The limit of a constant c times a function. This is a combination of theorem 1 and theorem 2. So we have this. This means to say that the limit of a constant c, this one, times a function is equal to c times the limit of the function provided that f of x exists. So that means to say, what are we going to look for with this is we will just go on with the approaching value of x again. So approaching value will be substituted to the function. So let us have an example. Let us consider that we have this limit of 4x as x approaches 3. 4 is the constant and x is our function. Hence, we are about to substitute the approaching value of x to x here. So approaching value of x is 3. So we are about to substitute that here. So it happened that it will be like this. So for this constant value, times the limit of x as x approaches 3. So as I have mentioned, you are about to substitute this approaching value of x to x. Hence, this become times 3. So limit of x as x approaches 3 become 3, like the second theorem. And you are about to multiply 4 times 3, and that is equal to 12. Let's have another one. Limit of 6x as x approaches 8. So the constant is 6. The function that we are talking about is x. So constant times the limit of x as x approaches 8. Then what will happen is we are about to copy 6 and we are about to substitute the approaching value, which is 8, and 6 times 8, that will be 48. That's all about the third theorem. Let's have the fourth one. The fourth one is limit of the sum of two functions. Hence, when we talk of the sum, it is about addition. In symbol, we have this one. The limit of the sum of two functions. The first function is f of x. The second function is g of x as x approaches a, is equal to the sum of the individual limits. So you get the limit of the first function, which is f of x, and you get the limit of the second function, which is g of x. Let us have an example. Let us consider that we have the limit of the quantity x plus 1 as x approaches 9. That means to say limit of x is the first function and limit of 1 is the second function. So what happened is you're about to work on with getting the sum of the individual limits. So this is the limits of x as x approaches 9. Then the second one is the limit of 1 as x approaches 9. Okay? So that means to say we can apply Theorem 2 here, wherein we work on with the limit of identity function, and this is all about limit of a constant. And when we talk of limit of identity function, the approaching value is our limit, and when we talk of the constant term is our limit. Hence, since this is a constant, and that will be 1, and the answer is 10. So the limit of the quantity x plus 1 as x approaches 9 is equal to 10. Okay, let's have another example. How about this one? Limit of x plus 12 as x approaches 5. So we are about to get the individual limit of x as x approaches 5. We have that. Then limit of 12 as x approaches 5. That's plus. Okay, so we have that. Again, this is the second theorem. So the approaching value of x will be the limits, and that become 5. With this is a constant, and that will be the answer. Okay? So when you add 5 plus 12, that is 17. Therefore, the limit of the quantity x plus 12 as x approaches 5 is 17. Okay, that's the fourth theorem. How about the fifth one? The limit of difference of two functions. Mathematically speaking, when we talk of difference, it means to say that we will be working with subtraction. So let us have the symbol. It's the same as addition, only differ from the symbol that we will be using. Okay, the limit of two functions f of x minus g of x as x approaches a is equal to the individual limit of the first function, which is f of x as x approaches a, and the limit of g of x as x approaches a also. So talking of that example, we are about to work on with an illustration. Let us consider that we're having this one. The limit of the quantity x minus 12 as x approaches 9. So you are going to get the individual limit of x as x approaches 9, minus limit of 12 as x approaches 9. So this is theorem 2 again, and this is theorem 1. So the approaching value of x will be the value here, or the limit, and that will be 9. then the constant term is our answer here. Then the limit of x minus 12 as x approaches 9 is negative 12, since 9 minus 12 is negative 3. Let's have the next one. How about this example? The limit of x minus 7 as x approaches 2. That means to say, getting the individual limits of this again. So limit of x as x approaches 2. Okay, minus limit of 7 as x approaches 2. Applying again theorem 2, approaching value of x will be the limit. Then the constant value will be the limits, which is 7. And 2 minus 7, that will be negative 9. Therefore, the answer is limit of the quantity x. Therefore, the answer in limit of the quantity x minus 7 as x approaches 2 is negative 5.